mathematical literacy. We are going to look at today's lesson, which looks at summarizing and representing and analyzing data. My name is Mr. M. Sibanda, Mlungisi Sibanda. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pagama Research and Development. Our WhatsApp number is 0827602630. I will start the lesson with you. I'll start on recapping what we did the other time. We had a very nice example that we looked at. But before I do that, let's look at terminology as well. So I want you to be reminded that we have the following terms in data handling. Biased questions, we look at if the question is biased or not. Is it fair? Is it not asking unnecessary information? Is it not sensitive to certain issues? Now, we also looked at categorical data, numerical data, and we split our numerical data into discrete and continuous, where we say data can either be discrete or continuous, or we also looked at categorical data. Now we're going to move on with the summarizing of our data and representing it today. So I want us to look at the example that we looked at the other time. This is where we're looking at the measures of spread, and sometimes also called the measures of dispersion, which we said it measures how far or how wide our data is spread out. So it looks at the spread in our data. So we are going to look at the range and interquartile range. So there are two measures of spread, and these two are the range and the interquartile range. And as you can see, they're all range. And we're going to specifically look at the quartiles for us to determine the interquartile range. So the quartiles are values that divide our list of numbers. Remember, our list of numbers is always put in order. So we always put our list of values in order. Then once the list of values is in order, we then now cut our data into four. The first quartile, second quartile, third quartile, and we go up to the end there. We'll have the minimum and the maximum right at the end. Now, I want us to look at these three. In fact, look at these three. We want to calculate the Q1, Q2, and Q3. Now, this is the example that we did last time. It says use the exam results out of 100 marks of a group of girls and boys to answer questions that follow. The marks are arranged from lowest to highest. So we have 40 up to 84, 12 up to 91. And we need to calculate separately for boys and girls. Now, then thereafter, we need to compare the results of these two groups, and then we're using the interquartile range. Now, what I'm going to do, I'll give you a minute to do the median for me, which is Q2. And please do the median for me, and I'll give you 1 minute. After that minute, we come back and I will do the rest, which is the Q1 and the Q3. Thank you very much. Thank you. Welcome back. I hope you did calculate the median for me then. Now, remember what we said about the median, it is the middle value, so we're looking at the middle value. So there are 16 marks for boys and girls. So for the girls, let's start there, it's 40, 40. So we will see that the middle value is here. Now, let me fix my pen. Okay. Right, yes, the middle value is here. Okay, my pen is playing with me. Yes, the middle value is there. So the middle value will be between 61 and 64 for the girls. So we'll do the addition there, median. We'll add the 61 plus 64 and then divide by 2. And the answer there is what? Now, the answer there is 62.5. 62.5%. So the median for the girls was 62.5, and that gives you the Q2. So the Q2 for the girls, I'll write them here. Q2 is 62.5%. And now let's look at for the boys. The boys, the middle value there is between the 55 and the 57. So our Q2 therefore will be equals to 55 plus 57, and then we divide that by 2 because we want the middle value there. And the answer to that is actually 56. So we're getting 56%. So our Q2 for the girls, it's for the boys rather, is 56%. And now we go into the first half and look for the median of the first half. In other words, we're looking for half of this half. So you discover that we have 8 numbers here. So 8 numbers, the middle number is between the 4th and the 5th. And therefore our Q1 for the boys, for the girls is there. So which makes it 46 plus 49, and we divide that by 2. So for the boys, the Q1, for the girls, I keep on interchanging them. But you'd realize that I'm doing the girls one, which is 46 plus 49. And then we divide that by 2, and the answer is 47.5. 47.5. So the Q1 for the girls is actually 47.5. And then we now do the Q1 for the boys, or should I do the girls and finish? Yes, let me do the girls. So it's 1, 2, 3, 4. And therefore the Q3 now for the boys is actually, for the girls, yes, it's 70 plus 72 divided by 2, which will give you 71. So our Q3 is 71. Then let's look at the boys now. So the boys, we identified the median as that number there. It's between 55 and 57. So I count 1, 2, 3, 4, and my Q1 is therefore between 45 and 49. Divide by 2, and the answer there is actually 47. Yes, 47. Very close to the girls one. 47. And then our Q3 finally for the boys. So we count 1, 2, 3, 4, and we are here. It's actually 73 plus 76. I'll write it nicely there. And then divide by 2, 73 plus 76. And the answer is actually 74. Right, 74.5. 74.5. So those are the quartiles for the boys and girls. Now, remember we tried to answer this last question where we're saying we want to compare the results using the interquartile range. I'll remind you of what we said is the interquartile range. So interquartile range is actually Q3 minus Q1. Now, I want us to do for the girls here, and we look at their IQR. We also call it the IQR, interquartile range. So it's going to be Q3, which is what? Q3, which is 71 minus 62.5. And the answer is 8,5. So the IQR for girls is 8,5. And then for boys, the same IQR is actually equals to 74.5 minus 47. Yes, 47. And the answer is actually 18.5. I hope you see that because I've clustered everything all over. Now, let's now answer the last part. We've got all our results now. We've got our interquartile range, and we've got the values for the interquartile range. Now, here is where you need to listen to me very carefully, because if we don't get this right, we will miss out this one, and we will not interpret the question correctly. So if you check there, the boys have an interquartile range of 18.5, and the girls have an interquartile range of 8.5. And therefore, the performance of boys is inconsistent. In other words, they have a huge, there's a huge difference between the marks there. Because the higher the interquartile range there, the higher the differences we have in the values that are in the middle. Because the advantage of the interquartile range is that it ignores all these other values like the 91 and the 12. If you look at the boys, they have a 91 and a 12, which makes them very inconsistent. One of the boys has got a higher mark, but as well as the lowest mark from the same group of boys. So then the decision then to say which group performed better will then be the girls, because their interquartile range is smaller, meaning there is a lot of consistency in their marks there. They have performed better because they are consistent. Their marks differ slightly than that of boys. Right. We'll move on to the next part. This is the summary of this. I want you to look at this, and when we come back, you tell me what you think about this. You can send your questions or your comments on WhatsApp on 0827602630. I'll come back and discuss the advantages and disadvantages of each of those measures of spread. Thank you very much. Join me after 2 minutes. We'll come back and discuss this.
You have been given power to decide whether you want good results in your life, in your schoolwork, or you want bad results. As Tony Robbins said, it is in the moment of your decision that your destiny is shaped. And your destiny is shaped right now with the decisions that you are currently making in your schoolwork. So decide whether you want to be an A student and start working on it, because there is power inside of you. The infinite power is inside of you, and the time you decide to tap in that power, you will become who you want to become in your schoolwork.
Excellence. Excellence is a habit. Excellence is a quality you have, a quality I have. It's a quality we have when we honor what is true to us. Yes, we are gifted differently. uNkulunkulu akasinganga ngokufana. Excellence is striving for your best. Whenever you have a particular project, test, homework, uzibuze, ask yourself, is this my best? Can I put in more effort? Excellence is striving to be in the top 1% of the area in which you are gifted. And so I challenge you, in every single thing that you do, in every single area that you're gifted in, whether it's sports, it's academic, ucula, whatever that gift is, strive for excellence.
Do you know that you are different? Do you know that your fingerprint is different? Is different from your peers, from the people that you are studying with. So do not compare yourself with your peers. Do not compare your results with what they're getting, because you are different. You have your own talents and skills, and also you have your own gifts. Embrace what you can do. Always put in the work to make sure that your results become better than what they were yesterday. But do not compare yourself, because when you compare yourself, you do not know what another person has, and they do not have what you have. So believe in yourself. You are different, and keep on putting the work.
Thank you. Welcome back. And this is what I want us to summarize there about the measures of spread. There are two that we do in Maths Lit. The two are range and the interquartile range. Now, the interquartile range and the range are all measures of central tendency, but this is where the advantages of the range are. It's easy to calculate. Maximum minus minimum, you've got your answer. But the disadvantage of the range is that it's affected by extreme values. So sometimes you might find that you have one score that is very small, and the rest of the scores are neatly close together, and therefore your mean, your minimum will affect your range, because you're gonna take one of the values, the largest value minus the minimum, and you're gonna get a very huge difference. And by looking at the range, somebody would think, oh, there are huge differences in the marks or in the scores, right? And the interquartile range, the advantage now is that it's not affected by extreme values, because it looks at the middle values. So it looks at the 50% of the values in the middle and ignores all those values at the ends of this data, because you have written your data in order. The first number and the last number are all ignored, and you go in the middle and you see what is happening in the middle. So you are like somebody who's getting right there in the mix of the things and looking at what is happening, and you get a clear picture because you are ignoring the outliers. We call them the extreme values. So those are the two advantages. But one thing that is not right with the interquartile range, rather, that is taxing. It is it's time consuming. You need to put your numbers in order, and if you have a large amount of numbers, it's then difficult to calculate, and therefore you'll end up using some graphs and all of that, and it takes a lot of time. It's time consuming. So let's move on to the next part. This is the summary of all the lessons that we did on summarizing our data. So we have there at the top measures of summarizing, how to summarize your data. So when we summarize our data, we either look at the measure of central tendency, which will be 3, mean, mode, and the median. Maybe I should have put the median in the middle there so that you remember that it is the middle value. And the mode, most, the one that appears the most, the one that has the highest frequency. And the mean, normally anybody in the street will call that an average. But remember, all of these are also called the averages. So when we say averages, we're referring to all of them. But when we say the average, in most cases, we are referring to the mean. But all of these, let's remember, in maths literacy or anyway, they are called the averages. And then we have the measures of spread. There are two that we look at. We look at the range and the interquartile range. I hope you remember the IQR, the interquartile range. Remember, when we use the range is used to measure the spread of our data. In other words, we're looking at the variety within our data. Now, I've stressed the point that it's not desirable sometimes, but there are cases where you need your range to be huge. Like if you go to a shop and you are buying things, you want to be accommodated. So you want a huge range that will accommodate the rich and the poor, everybody there is actually accommodated by that shop. So the range measures the spread, it measures the variety. So if you've got a huge range for a shop, that's desirable. That means you go to that shop, you will get what you want. Everybody will get what they want. But in a class situation, your teacher would not like to teach a class that is a high achiever and a low achiever in the same class. The approach will be difficult. You know how to pitch your lesson. You know how to teach your class, how to remedy those who are not doing so well. But if the range is smaller, that means these people have the same ability, or basically a close ability. They function the same way. Same thing with the IQR. You ignore all the other extreme values. So you are far from the madding crowd, and you go in and check what is happening in the middle of the things, in the mix of the things, and you want to find the range between the upper quartile minus the lower quartile. That summarizes our lesson on summarizing data handling. So we summarizing our data using these measures. Now, I want us to move on to today's lesson, where we are looking at now representing our data. Now, when we represent our data, we are using graphs. You know, people don't like reading. You know, you put a lot of things. If you want to hide things from people, write it down. They won't see it because they don't read. But if you want to tell a story, you want them to see things visually in a picture form, in a pictorial form, you then use graphs. And graphs will come in many forms. Bar graphs, I don't know how many types of bar graphs we have. There are so many. We'll list them as we go. So bar graph, histogram, line graphs, pie charts, and scatter plots. Right, I'll add the other one, which is the box and whisker that we'll start with. So when we draw a bar, a histogram, a line graph, we expect you to draw these, by the way. We expect you to draw the bar graph, histogram, line graph. We don't expect you to draw a pie chart. So pie charts, you only interpret. And the other one that you interpret is the box and whisker. And from there, we expect you to read the data that is contained in those graphs and analyze it and interpret the summarized data. So here are some questions that you have to ask yourself, or things that you need to consider when you are looking at graphs. So like I've said that one, we represent our data visually. Now I've given you the types of graphs. I'll move very quickly there. Line graphs, bar graph, histograms, histogram. I'm repeating myself. Pie charts, scatter plots, and lastly, box and whisker plots. They're called plots or diagrams. Someone will want to call it a diagram. Same thing. Whisker plots or diagram. All right. Now, things that you need to look at. Right. Number one, you need to remember when you're interpreting a graph, the type of graph that you're dealing with and its limitations. You need to remember that each time a graph is drawn, it must have a title or a topic. It must have labels. The axes must be labeled. The axes must be there. And what axes am I talking about? The independent, dependent axis, which will represent the dependent and independent variables. And you need to look at the relationship between variables. That is why you're drawing a graph. The graph gives you that pictorial view of your data. Now, you also need to see trends. We'll come back to these trends. What trend do you see represented by data? And are there any changes in your graph? And what are the reasons for those changes? Now, let's look at other things that you need to ask yourself. Because data handling can be misleading. We can use data handling to mislead. Is there missing information in your graph? Do I have enough background information to analyze this data? Is there extra unnecessary information that is given to you or data that is given to you? Based on this data, can we project for the future? Can we then forecast about the future. And there comes the probability. Then we talk about probability. Can we put probability into perspective there? Can we try to, project about the future, forecast? Who could use this data? That's another question that we ask ourselves. Then we conclude and make a conclusion about the graph. So I want us to start with a box and whisker. This question is adapted from Western Cape Education, September 2019. Right, Department of Education of Western Cape. This is what they gave their learners in 2019 as a question in paper 2. Statistics were gathered from basketball players, baseball players, to determine the distribution of their height. So the data here is about the height of these players. The box and whisker plot below shows the height of basketball players and baseball players in inches. I know you are not expected to draw a box and whisker, but I'll try to explain it to you. Right. The box and whisker summarizes the 5 numbers that we looked at yesterday or the other day, yes, on Wednesday. We look at the 5 number summary. So 5 number summary. And what are those numbers that we summarize? We look at the minimum. We look at the Q1, which is the lower quartile, and we look at Q2, which is the median. We look at Q3, and we look at the maximum. So what you get from your box and whisker are those 5 numbers. Remember, we're summarizing our data, but now we're displaying our summarized data using a graph. So, for example, let's look at the basketball. Now, the reason why they call this a box and whisker is because you've got a box here, right, that starts here, and there's a middle value there, or some value may not necessarily be in the middle, but somewhere between these 2 values, and this is a box. And then these are whiskers, like the cat whiskers. You know the cats have these hairs that grow like this. Those are whiskers. So this is why it's called a box and whisker. So the number that starts here is the minimum, right? And the first value in your box is your Q1. And the middle value, or the value that is displayed here, is your Q2. And lastly, in the box is Q3. And then the last value here is your maximum. Please do not always use the last value on your grid there. Your grid or your line can go up to 300, can go up to whatever value. But the last value that you're looking at is this one, the maximum. And this one is the minimum. So I'll come back to that so that we answer the questions that we are given there. But I want you to remember what we get out of a box and whisker. So box and whisker displays our 5 number summary that we talked about the other day, which is the minimum, Q1, which is also called the lower quartile, the median, the upper quartile, which is also called the 3rd quartile. And then it does give us the maximum. So we can see the range out of the box and whisker. We can also see the interquartile range out of the box and whisker. And what else can we see? We see the median. The median is in the mix of the things there, and it is part of what we call the measures of central tendency, and it is the average, therefore. So I want us to answer the first question there. And the first question that we have is verify through calculations whether the difference between the IQR of the basketball players and the baseball players is 3 inches. Right. These players are in America, so that's why we have inches there. Never mind the units there. We don't use inches. We use meters, and centimeters and the like. They are using those units, the imperial units. We use the metric units. So let's start by analyzing the first part. If you check the minimum for the basketball players. Now, the other thing that is very critical for you to do is to check your scale on your graph there. You must check your scale. So if we check here, we're starting from 64, and this number that is here is 65, then 66, then 67. So that means This number here is 67. The numbers do not always go in one. The scale doesn't differ by one. Sometimes you find a scale that goes in twos. Let's say 64, 66. Already next the value is 66. So that means in the middle of the values will then be 65 or halfway there. So let's look at this one. The Q1 is 68. And then the median for this one is 74. The upper quartile for this is 79. And then the maximum value is 85. So it's 85 inches. That is the tallest player there in the basketball team. And then for the baseball, the minimum is 64, and then it's 66. That's your your Q1, the lower quartile, and the median is 70, and then your upper quartile is 74, and then lastly your maximum is 76. Now let's answer the question. Let's do the IQR for the basketball players. So let's do the IQR, and we're saying this one is for basketball players. So these are basketball players, and it's 85, the maximum, and we are looking for Q3. Remember your IQR, it's good to write the formula. It's Q3 minus Q1. What's your Q3 there? 79 minus your 68. And what does that give you? It will give you 11. So that means the IQR for basketball players is 11 inches. The difference in the middle, I want to stress that the difference in the middle of the values of the basketball players is 11. Now let's look at the other players, which is the baseball players, and we are looking at baseball. I can write this one in full, and we are saying it's 74 minus 66, and that gives you a value of 8. And therefore the question, let's go back to the question. The question says verify. So one could be happy by getting those and say, I'm done. You're not done, because you haven't answered the question. The question that says verify must end by saying the claim is correct or is incorrect. So we must, at the end of our calculation, then verify the claim or verify the calculation, verify the statement, and write down in words that this is correct or incorrect, because we now need to say, okay, what's the difference? Difference implies what? Implies we subtract. So the difference between the IQRs, it's actually 11 minus 8, which is 3. And what was the claim? Let's go back and see what are we verifying? We're verifying that the IQR, the difference between the IQR of the basket is actually 3. Between the basketball players and the baseball is actually 3. Now, did we get 3? Yes. So we are going to end this question by saying the answer is actually yes. It is correct. And that will give you full marks if you're writing an exam. But if you just do the calculations, you'll only get half the marks, or not half, but you'll get -1 mark, because you haven't done the conclusion, because we need the conclusion. By saying verify, we want you to write a statement that actually verifies. The next question is easy. What is the average height of the baseball players? This one I'm going to give it to you. I want you to think deeply, and I'll come back and give you the answer. It's only one word. We are saying the baseball. It's only one number that we want there. We want what is the average height of the baseball players. So focus on the baseball players and check what information about the height are you given by the box and whisker. After a minute, I'll come back and give you the answer. Thank you very much. Join me after 1 minute and keep on sending those questions. Thank you very much. Thank you very much. Welcome back. Thank you very much. Welcome back. I thought you got this one very well because we explained the average. Now, when you're looking at the box and whisker, the box and whisker is more on the measures of spread. So, but there is one value that is an average. The rest are not measuring the average. They are measuring the spread. They help us measure the spread. And that value is your median. Because when we say average, remember your average is, don't forget this, very critical. Your averages are 3. It's the mean, mode, and the median. And when we have a box and whisker, there is only one average that we have there. So one of those averages is just one, it is the median. So we come back here and say, okay, what is the median of the basketball players? It is 70. So therefore, the average that we see on a box and whisker, there it is the 70. So on average, the baseball players are 70 inches tall. That's the average that we have there. Otherwise, we don't get any other average out of a box and whisker. It is only the median that is shown. So if a question asks for the average, it needs to be clear what average is it talking about. It doesn't give you the numbers, so therefore you can't calculate the mean. It doesn't give you the numbers, so therefore you can't calculate the mode. So you only get the median from this data set. So that is what you get from the data set. So the median is the only answer that we have there. So the average height of these baseball players is actually 70 inches. Thank you very much. So we move on to the next part where we say if the data was collected from 84 basketball players, right? So when we drew this graph, we used 84 players. So in other words, the maximum and the minimum that we given here is for the 84 basketball players. The question, it's a tricky question. It says, answer this question, calculate the number of basketball players who are 79 inches taller. So we need to go to the data and look at the basketball players box and whisker. And we ask questions now. If we look at the basketball players, the minimum was 67. The Q1 was 68. Definitely there's nothing to do with the 79. And the median was 74. And there we are. We're having our 79. If you check there, 79 is actually your upper quartile. That's your Q3. So this is a theoretical question because we need to understand what is Q3. What do we get out of the Q3? The question says calculate the number. So we need the actual number of players there that were taller. In other words, greater than the 79. Now, remember what the quartiles do. I'll draw this box to make you understand. The quartiles do this. They divide our data. First, we divide our data into 2. We get Q2. Right. So in other words, I have 50% and 50% this side. And then if I divide the second half of the 50%, and then I get what? Q3. Now, that means this is now 25% and this is 50%. If I subdivide again there, I'll get Q1. So I've divided my data into 3. 1, 2, 3, 4. So that means from here to there, it's going to be 75. That means 50, 50, 25, 25, 25. And therefore, your Q3 stands at 75%. So 75% is below your Q3 and 25% is above. Now, above means more than. And when we relate to the data that we given there, when you're saying taller, if somebody is taller than 79, that means they are more than 79. So that means they are above the 79. So looking at our percentage there, 25% of the values here are more than the Q3, and our Q3 is 79. So therefore, the number of players that were more than 79, number of players more than 79 will therefore be 25%, which is 25 over 100 times the number of players that we had. We had 84. So if you take your calculator, 25 over 100 times 84, that means a quarter of those, and the answer, your calculator, that's going to give you is 21. So there are 21 players that were above the 79 inches. Now, very critical to remember what your quartiles tell you. Your Q2 tells you 50, 50, 50 below, 50 above. Your Q1 tells you 75% above, 25% below. But your Q3 tells you 25% above, 75% below. So when we say 25% above, we need to know the number. We've given the number. It was 84 players. So we calculate 25% of 84. That's how we do that question. And we now do the last part of that. A data analyst states that 75% of the baseball players. Now, remember, whenever we're looking at 75%, think Q3, 3/4. 3/4 is 75%. So when we are looking for Q3, rather, 75%, we go Q3. And then it says there, 75% of the baseball players. So 75% of the baseball players, we now look at Q3. That means 75%, our Q3 for baseball is 74, right? And then it says are shorter than 50% of the baseball players. So 50% implies Q2, median, middle value, 50%, half. Remember I said half empty, half full. But we are looking at Q2, which means 50%. So 50% of the basketball players. So we go basketball players, we're looking for 50%, we're looking for the middle, the value inside our box there. And that value is this one. So what is that value? Oh, our Q2 for the basketball players is actually equals to 74. Now, Q3 for the baseball players is the same as Q2 for the basketball players. So remember, 50% is Q2, 75% is Q3. Now, let's read the statement. It says, validate this statement. Back to that question where we validate, we find truth in the statement that is given to us. We find value to say, what value, is it true, is it false? All right, this validate this by referring to the quartiles of the different data sets. And this is what we have done. Now, let's validate the statement. So, if basketball players have a Q2 of 74, that means half of the basketball players are actually below the 74. And now look at the Q3 for the baseball players is 74. That means 75% of the baseball players are actually below 74, which then makes them half of the basketball players. So in other words, 50% of the basketball players are actually taller than the baseball players. Because if we look at the 50%, which is more than this number, 74, and they are actually taller than the 75% of the baseball players. So this then says the statement is correct. The statement, okay, I've lost that one. Coming back, the statement is actually correct, right? So that validates that statement. He is correct. It's 100% correct because their Q3 and the Q2 are equal. The Q2 for the basketball players is equal to the Q3 of the baseball players. So that validates that statement. Now, I want us to move on to line graphs now. Line graphs give us more information as well because it gives us the trends. It shows us what is going on. The graph alongside shows the average number of minutes per month that Jabu spent watching TV. I know some of you are watching TV a lot because it's a holiday. It's okay. It's okay. When we come back, TV must take a back step. Ne? So this is from January to November. Now, before you answer any question, remember what we said we must look at. Is the title there? Yes, there is no title. It's missing. But we will put it there and say this is the line graph showing Jabu TV activities. Ne? And now we have the axis labeled. So what do we have on the axis, on the y-axis here, or on the vertical axis rather? Then this is viewing time. So that means in January, Jabu watched TV for 108 minutes. So 108 minutes he watched TV there, and going on until what? November. So before they ask you a question, you should be looking at the trends or some pattern that is going on here and checking if you really understand. Now, this one, I'll give you a chance to answer and tell me what is going on there. But I'll guide you here and there. And what I want you to tell me is what trends do you see or patterns? So when we look at the trends, we're looking at the patterns. What is going on with our data? Because we can track the changes that are going on here. We can track that he watched a lot of TV in February, he didn't watch a lot. So we can see the trends. I want you to analyze this data and give some possible reasons why these things were so. I'm going to give you about 3 minutes for this. It's a bit long. You tell me what trends you see there. And I'll come back and analyze with you after 3 minutes. So see you after 3 minutes. Send your questions on 082-760-2630. Thank you very much. See you after 3 minutes. you. Welcome back. I hope you analyze the trend. So every time you see that word trends, it's actually asking you to find the patterns. Identify any changes that are happening within your data. Like I said, the advantage of this graph, it shows us the changes. You can track the changes as they happen. Now, let's analyze them, and we start where the graph starts. We start in January. What are we saying in January? See the general part, the viewing time dropped. So you could then start by saying there is a drop in February. And what's the possible reason? So Jan to Feb, there is a drop. You need to write in full February there. Jan to Feb, there is a drop. Right? What's happening there? Possibly it was a school holiday in January, and all of a sudden schools are open. You can't be watching TV all the time when you have books to read. You have maths literacy to do. You can't be then watching TV all the way. But there is a sharp increase. So these are the words that you use to describe a trend. There is a sharp increase or a gradual increase, but here it's a sharp increase. There is a sharp increase. Sharp increase. You need to say the specific times when these things are happening. Sharp increase in April. And not only in April, and what time as well? In June. So there's a sharp increase in April and June. What's the possible reason? Maybe it was a holiday. Maybe it was a holiday. Let me not say maybe. It was on holiday. We know when our school closed. Our school closed in June. Our school closes in June and April as well. And then there is another increase in September. You can see that's a short time span, because in September our holidays are shorter. So, and September, and then it decreases. Let me talk about this part. It decreases June and July. In fact, July to where? To August. So to August, the viewing time, there is a decrease there. So the viewing time decreases. And what's the reason? He's writing exams. And this is exam time. We can write that, examination time. So he could be writing exams. Yes. Chabu was writing exams there. And in November and October and November, same story. There is a decrease. There is a decline. I want to use different words so that you remember. Decline, decrease, drop, sharp increase, gradual increase, or steady increase. Those are the words that you must use to describe trends. And I've also given the reasons for those patterns, for those changes. Now, the next question that we want to answer, we have already answered this question to say, what are the advantages of this type of graph? What is the advantage of using a line graph to show this information? So the main advantage, one can track changes. One can track changes. So you can actually follow changes. That's what I mean by track. You can actually follow the patterns or the changes that you're there. They are visible. Unlike when you write a story, you say Chabu was watching TV in January, then he stopped watching TV. Before I even finish what I'm saying, you would be sleeping. But if I draw a graph, the graph captures the whole thing nicely, the happenings actually nicely at that given time. And with this, you can even draw two graphs in one. If Jabu had a friend and the friend was also watching TV, and we say in January the friend watched 110 minutes, and in Feb this friend doesn't read books, doesn't like books, was on that, and we go up in, he's going up, he's watching TV on and on, he doesn't have a stop. And let's say he stops there because he's now sick, or something else, and then increases the watching. You see now, we can track both graphs for Jabu and friend. So we can actually follow the changes of those two people. So that's the main advantage of a line graph. So we can actually draw two graphs in one and follow the changes and maybe color them differently. So you need to remember that. When we ask you to draw a line graph, we'll specifically say draw a line graph. I've seen people drawing line graphs when they were asked to draw bar graphs. So when the question says draw a bar graph, draw a bar graph. When it says draw a graph, a line graph, draw a line graph. Right. And then we also look at another type of graph, and this time it is the bar graph. Bar graph, as the word says, they are bars. So you'll see the bars, and these bars are drawn separately, they are spaces, and there is a reason for that. Let's read this question. Does this graph have a title? Yes. So we can tick the boxes on this graph. And does it have the axis labeled? Yes. So this is a perfect graph. And do we have anything that is amiss on this graph? Anything that doesn't look right, queer? No. So this graph is not meant to mislead anyone, because you will answer questions that will ask you to say, how is this graph misleading? But this one, it doesn't mislead. Now, I want you to answer this question that we have there. The school tuck shop keeps track of how many hot dogs, sandwiches, and salads and burgers they sell at one break time. So this is just one break. This is not many breaks. So this information is just for one break. They have the data given in the graph alongside. So we have that data. Now, I want you to explain to me why the data displayed on this graph is classified as categorical. I hope it comes clearly there. If it doesn't, we'll get that question. I'm reading it for you. Why is this data that is displayed here categorical data? I'll give you a minute to discuss that, and we come back and we discuss why we say that type of data is categorical. 1 minute only, not long. Thank you. Now, we need to explain. The question is asking us to explain why this data is classified as categorical. Now, if you check there, we're saying hot dogs, sandwiches, salads, burgers. So these are foods that are sold in a tuck shop. These are items that are sold in a tuck shop. And we remember what we said about our data. We said our data is either categorical or numerical. So if it is numerical, then we further describe it as discrete and continuous. So in other words, we further classify our data as those three there. Discrete is when your data only exists in certain numbers, that is whole numbers, and you can't have it as fractions or decimals. And then continuous is when your data can be any number, it's got by measuring. I'm reminding you of those things. And when we say categorical, this data exists in description. Now, hot dogs and all the other foods, these are descriptive. These are words. So that is why we say that is categorical. So the reason for that is that the data is descriptive. In other words, it describes, or you could say it's given in words. So every time you're given things in words like favorite team, favorite color, those type of things are actually, that type of data is actually classified as categorical. So that's the reason why we're classifying this data as categorical. Now, the next question that will come up, because like we said, the graphs show us what you call the pictorial view, the picture about the data. It gives us a view that is clear, because like I said, most of us don't like reading. We want to see things. Now, the second question is, what is the most popular food sold by the tuck shop? If I were to ask that question differently, I would say on average, what food is bought by the learners? It is the same question, because when we say most popular, remember the word most. Most will therefore be mode. So mode and most. So what is the mode of this data? So it's easy, because this is given pictorial. We look at the longest bar there. Which bar is longer? It is the sandwich. Sandwich is longer there, and this means the sandwiches are actually your most popular food. So learners love sandwiches there. They love the sandwiches. So that's the most popular food that we have there. Now, next question. That's a very easy question, and we can see from our data, because the graph makes it easy for us to see, especially the bar graph. It makes us to see things in a different light, more clearer. Now, how many food items were sold? Now we're asking for the number of food items that were sold. Remember, we're reading from the graph. Now, how many hot dogs were sold? 15. How many sandwiches were sold? 35. So we're going to add the numbers. So the number of items, we're going to just say 15 plus 35 plus 10. And I'm reserving the last one for us to think now. Now, the last one, as you see there, it's not clear cut. It's actually between 10 and 15. Now, in this type of a question, the examiner and even the markers know that this is not very clear, because you don't have the raw data anymore. That's what happens when you process your data. Remember, when we started, we say data handling starts with a question. You have a question, you collect your data, and after collecting your data, you classify your data. And then when you now have done the classification and organizing of the data there, you've organized the data, the organization is done, you now summarize your data. So you once you summarize your data and then display your data, represent your data, you lose the original data. So now we're going to estimate. So any value that you're going to give there that is sensible, it must be above the 10 but below 15. I would say this, suppose this is 11, 12. For me, that is 12. Someone will say 13, 14. I know we can argue. That for me is 12. So if you add 15 plus 35 plus 10 plus 12, you will get 72. Now, remember what I said. You are allowed to give us an answer that is different. You could have said 13 there, your answer was going to be 73. You could have said 14 there, and your answer was going to be 74. You can't say 15 because this value doesn't touch the 15 there. So that is acceptable. You can give us that. Remember, your graphs sometimes end up rounding off, and you end up estimating. This is why when you're doing your sum, sometimes you try to get the total. The percentages sometimes do not add up to 100%. They come up to 99.9. It is through estimation. It is through refining our data. So you can expect to answer a question like that from the examiners. Now, This we are not going to answer any question. I'm just going to show you that we have a multiple vertical bar graph as well. This type of a graph actually is very helpful for comparison purposes. If you check there, the blue line is for Western Cape. The next line, or the next bar rather, is for Gauteng, Eastern Cape, and KZN. I could not put all of the provinces there because the data was going to be, and in fact the graph was going to be longer than what we have there. It does not fit there. But this is just representing a few provinces. These are number of reported COVID cases per province. That was at a specific time. You'd see there it's 2020. So you see the bars. We are able to see that, Western Cape at that time had higher cases there. And remember, the other provinces caught up, and very soon the wave was everywhere. And you can compare using the multiple vertical bar graph. So it is still a vertical bar graph. It is still a bar graph. The reason why we make them touch, because we want that to be compared to the other component. We want to compare this event at this time and at that time and at that time. So that is why they touch. But otherwise, your bars do not touch on a bar graph because your data is mostly discrete, or even the first one that we did. It's even categorical. Now, I want us to answer this question, the next coming question. Now, this graph now is a stacked bar graph. So we stack the bars because this relates to the same time. So if you check here, I will do the first one, which is the 23rd of April 2020. The number of cases there for the positive cases and recoveries, they can be compared. So the reason why we draw a stacked graph, we want to compare things that have the same things, same phenomena, or different. Or we just want to compare things. The key word for bar graph, it's used for comparison purposes. Now, I want us to answer this question. I'll give you time to answer this question. 5 minutes will be enough. And I want you to use the table. I've removed the table. So I'll remove this table. It's the same table that we have. But I want us to use the graph below to answer the questions that follow. Is the data displayed in the graph discrete or continuous? Explain. Approximately how many recoveries were recorded in week 5, and so on and so on. I'm going to give you 5 minutes, and you'll see we have a general knowledge question there in D. I'm going to give you 5 minutes to answer those questions. Touch base with me after 5 minutes where we unpack and answer those 4 questions there, or 3 questions rather, that we have there. 5 minutes. Welcome back. Let's answer the first part. Remember, A is not a question. Right. Is the data displayed in the graph discrete or continuous? Remember, we're talking about what COVID-19 cases. So we need to know the title of the graph so that we analyze it properly. And we also need to look at the axis, number of cases, and this is week 1 up to week 5. So being the number of cases, this is talking about number of people. So therefore, the data that we are looking at there is actually discrete. And the reason, it's looking at number of people. So number of people can only be whole numbers. So the number there, or the values, can only be whole numbers. Numbers can only be whole. In other words, we can only get whole numbers or natural. So we can only deal with whole numbers there. So that is why that data is actually discrete. Approximately how many recoveries were recorded in week 5? That is a question that we need to answer. Let's look for week. Yes, there is week, and we're looking at week 5. So week 5, remember this is a stacked graph. So we've put data on top of another data. So we can look at the differences, or we can just estimate and say, okay, let's look at this value there. You actually need a ruler to do that. I used a ruler when I was doing this, and I look at below. Right, the total there is below 30,000. So one could say it's about 28,000 looking at that thing. So the recoveries that we're looking for, we are going to say 29 or 28,000, right, minus, I want the difference now. This is below 20, and this could be about 17,000 or so, because it's below 20. So it's above 15 though, so 17,000. And then the difference is actually about 9,000. Remember what we said, this is now an estimation. The actual values we do not know, because we have represented our data using graphs, and we are using a scale. So our graph loses the original numbers, the raw numbers. Now, approximately how many cases we have answered that question. Then the last question is a general knowledge question. And it says, give 2 ways that can be used to prevent the spread of COVID-19 disease. That's a general question. So you would go for, right, wearing of masks. Yes, we need to wear masks. Wearing of masks, and what else? Social distancing. Right, you know there are many ways. We'll stop there and say, let's wash your hands and move on to the next question. That's a general question. If you get that question, it usually comes with your data handling, because we want to see if you understand the context within your data. You need to always understand the context within your data. Now, the next graph that we're going to look at is the histogram. Histogram is different from a bar graph, and the main difference is here. The histogram is used to represent data that is continuous in nature. And most cases, you're looking at data that comes from measuring. So like you hear here, it says Luanda measures. If you listen to that question, it says measures the length of his school books. I don't know for what reason he wants to know, he wants to know how long those books are. And he measures them and then represents them and using a histogram. Now, the first question that we ask, state the model interval. Now, some learners will get confused by the word model. Let's look at how that word was constructed. Model comes from the word mod. So it's refined language there to say model interval. We don't say find or state the mod interval. Rather, we say state the model interval. So as much as we see the tall bar there in a bar graph, we also see it in a histogram. The main difference is that the histogram, the bars are joined. Why are they joined? Because the nature of the data is actually continuous. So the model then interval is therefore the one that goes up to 7, which is the highest frequency, the most. So it's actually 24 to 26.9 centimeters. That is the model interval. Now let's move on to the next part. How many books were measured? So if we are asked how many books, we then go to our graphs and even to our table and add the numbers. That's 4 plus 7 plus 5 plus 3. And that will give you 19 books. So 19 books were measured by Luanda. Now, let's go to the next bar graph, or to the next graph rather, not the bar graph. Now, the next graph is a pie chart. Now, pie chart, very useful to display data in a pictorial form, and they give us even more. Now, this is the context. The pie chart alongside shows a survey of the different types of favorite fruit juices, juice flavors, that are normally bought by a group of 120. So we need to know how many learners we have there, because we've lost that number, because our pie chart either gives us the percentages or it's drawn according to the degrees, because we measure the degrees. The bigger the slice, the bigger the numbers in that slice or in that group. Right, so let's answer the first question. The first question that we're having there is, calculate how many learners chose each type of juice. So we'll start where we have the 45%. So the people that drank the fruit cocktail were 45%. So most of us don't know what to drink. We just go for the fruit cocktail because it's got all the flavors. So we just drink fruit cocktail. It's 45%. 45% means over 100. How many people did we look at in our survey? There were 120. So it's 45% of 120. And then the answer will be 54. And you do the same for the other two. Luckily, they are the same. The lychee and the other one, the grape, yes. So the lychee, I like this examiner, I like this person, because it's 12.5, both of them. So once I calculate this one, I've calculated the other one. It's 12.5 over 100 times 120. That will give you 15. And that tells you the grape also had how many? 15, because the slices are the same. It's 12.5, 12.5. And lastly, we do the last one, which is the apple juice, the apple flavor. So the apple flavor had 30.5 over 100 times 120. And if you multiply there, we have a problem, because we're getting 36.6. Remember, this is number of learners, and it's 36.6, we have a problem. So what do we have to do? Because remember, this data is now processed, and the numbers are now processed, and sometimes it will not give you exact numbers. So we have to be clever here. 54 plus 15 plus 15, will it give us 120 when we add it to 36.6? No, it will give us 120. 6. So therefore, this will then be rounded down. Anyway, we round the number of people down in maths literacy. So there were 36 that chose the apple juice, right, as their flavor of choice. Now, let's go to the next part, which is now saying to us, in what way does the pie chart work better than a bar graph? The pie chart works better than a bar graph because it removes those bars and it shows us the comparison. It compares very well in one picture, not in different parts. So it puts them into one perspective, into one value. So it's good for comparison. So the pie chart compares well, compares better than the bar graph and even the histogram. Now, let's answer the last part of this question to say, what information would a bar graph give you that the pie chart does not give you. Remember, we had to calculate the numbers. So the actual numbers will not be shown in a pie chart. The actual values or the numbers will not be shown in a pie chart, but you get them in a bar graph. Now, the last episode, the last part that we're going to look at is correlation. So when we look at correlation, which will bring us this graph that we call the scatter plot. So the scatter plot shows us the relationship. It tries to find a relationship between two values that may not necessarily be the same. It could be your maths mark versus your English mark. Does your English mark influence your maths mark? So we're looking at the correlation. So what we do is we plot these two different things. We plot your maths marks versus your English marks, or whatever we're looking at. And we try to find if there is any correlation. So correlation doesn't really necessarily mean cause and effect. It just means there is some relationship. That means you will then have to investigate more. So the scatter plot shows you the direction, the strength of your data. It also shows you the shape of the correlation. So if the shape can be a straight line, so it means there is a linear relationship. These things, they increase at the same time or decrease at the same time. If you look at the first one, this is a positive correlation and it's linear. And this one is negative, yes. So this one is negative. This one, there is no correlation whatsoever. This is like water and oil. These things do not relate. So remember, when we're doing scatter plot, we're trying to find or establish if there is a correlation between two sets of data. And we looking at those maths marks and some tourism marks. If you look at this mark, this is odd, but the rest of the marks fall into a pattern. So there is some relationship, and what relationship is that? It is positive between the two sets of data. So in other words, if you give me a tourism mark, I can tell you your maths literacy mark. Right. Is there any point that you regard as an outlier and give a reason? Yes, this is standing alone. So this value here, the 5 and 80, is actually an outlier. Now, why are we saying it's an outlier? Because it stands alone. Stands alone. And it is actually out of place. It doesn't fall into the pattern. It doesn't fit the trend that we have there. So it is called an outlier. Now, is there correlation between the two sets? Yes, there is some correlation. We're very mindful of using absolute words. We say there is some correlation. So they will say there is some correlation. Now, I would have loved you to do this question, but I'll leave it for you to do, and I want you to check the answers out there. Now, this did not come out nicely, but I want you to go and look out for a question that was there in June 2019 for you to answer this question, to write down the age group. This was data on registered voters. So I will not go into detail into that question. I will ask you to do this question, and next time we meet or any other time, you go out into the net and look at this question, 2019 June, where we had a data handling question like this, which was asking learners to use this comparative bar graph. This is another type of graph. But next time, grade 11, we will answer these questions, and I'm not going to go into detail. I'll tell you it was adapted from the NCS June 2019. I want you to go to that website, look for that paper, download it, and answer that question. So last but not least, I want to thank you for everything, for the support that you're giving to us, and for watching this video. Now, in closing, don't wait for the opportunity to come to you. However, pave your way to success, and opportunities will flock to you and will indeed be successful. And thank you for watching this lesson. Please remember to sanitize, wear your mask, maintain social distancing, and keep safe. See you next time. Goodbye.